Homework Hotline, what is your emergency?
Hello and welcome to the Homework Hotline. I'm Lily, a senior at EGHS, and I don't answer your questions, but I do hand them over to our panel of teachers. There's Nathan.
Hi, I'm Nathan. I teach math at Emily Griffith High School, and I usually help with the geometry questions.
There's Becca.
Hi, I'm Becca. I also teach math at Emily Griffith High School, and I usually help with the algebra questions.
And there's Sam.
And I'm Sam. I can help you with any of your science questions. I teach science at the Contemporary Learning Academy.
Trust me, I've had problems that have confused me from time to time, but instead of being frustrated, why don't you call these guys? You can call them every Tuesday and Wednesday from 4:30 to 5:30, and our phone number is 720-424-1666. They love when you call because they can give you individual attention.
That's true.
Yes, we do.
Yep, listen to her.
You can watch the show in several different ways. For live broadcasts, you can watch us on Comcast Channel 22, Prism TV Channel 8007, or go to livestream.com and search for EGHS Homework or EG Homework Hotline. If you'd like to see some of our past shows, watch us on YouTube by searching for Denver DPS TV Homework Hotline.
Lily is also the trivia queen. She asks a new trivia question at the beginning of each show. Lily, you want to talk about today's trivia question?
I do ask a question at the top of each show, and the trivia question can be any subject, but today we actually have a history question. If you call in with the correct answer, you will win a prize. So today's trivia question is, what industry gave us time zones? And we will answer that at the end of the show.
Awesome. So if you think you have an answer to our trivia question, or really our main thing that we do here is answer homework questions. So if you've got a homework question, give us a call at that number that was given to you earlier. It is on the top right of your screen. It's 720-424-1666. But you can also get in contact with us a couple other ways. You can, if you really like, if you're phone shy, you can get in contact with us on social media at Facebook or Twitter at EG Homework. You could text us at 970-680-3771. We don't really get a lot of text, but you could definitely do it. Or you could also email us at homework@emilygriffith.edu. So more than just calling, but calling really is our favorite way, but you do have options there if you would like. We will be here till 5:30 to answer your questions, and also you could answer the trivia question before 5:30. All right, let's go to Lily. Let's get some social media questions answered.
This one asks, Mrs. B invested $30,000, part at 5% and part at 8%. Total interest on the investment was $2,100. How much did she invest at each rate?
All right, I can take that one, even though it's not geometry. So this problem, first I'm going to go ahead and make an assumption. Typically when you invest, it's for a certain time period. That is not included in this problem. So I'm going to just assume it's like a one-time, maybe a one-year investment. So she invested $30,000, part at 5% and part at 8%. So if you're watching, you look at my screen, what I'm going to do first, in these types of problems, we always want to just set our variables. So I'm going to go ahead and use A and B, where A is going to be her, like the amount invested at 5%, and B is going to be the amount, and I'm just going to do this, at 8%. So again, just setting two variables is going to help us kind of set up some equations and solve this problem. So you know a couple things. You know, first of all, that she invested $30,000, meaning that she invested this amount A, this amount B. If we add those together, we should come up with an amount of $30,000. So I will go ahead and write an equation. The amount invested at 5% plus the amount invested at 8% should equal her total investment of $30,000. The next part we're saying she invested part of it at 5% and part of it at 8%. Well, I'm going to go ahead and before I do anything is I'm going to convert these into decimal form so we can work with them in our algebraic equation. So when we talk about percentages, remember it's always out of 100. So we have 0.05, and down here also out of 100 we have 0.08. So my equation says, well, I invested part of it at 5%, so 0.05 times A as a return on part of her money. And we invested the other part at 8%, and that's part B. And the total amount of her return, her interest, was $2,100. So it seems like we get a lot of these kind of systems of equations problems on the show. And I think they're a little intimidating because you have two equations and it's, I don't know, if you don't remember the process, it can be a little confusing. So the first thing we need to do, because we can't solve an equation if it has two variables, is we need to rewrite one of these equations in terms of the other. So I'm going to change this one, and technically you could do it with either one, but this is the simpler equation. So it's going to be the easiest one for me to manipulate. So I can solve for A or B. I'm going to choose to write this, solve for A in terms of B. So all I'm going to do is subtract B from both sides. And I'm left with A equals 30,000 minus B. I'm going to take this new equation that I wrote, and I'm going to plug it all the way back in here into A. And this is going to basically give us one equation with one variable. So 0.05 times A, which we said is right here, 30,000 minus B. That's what I'm going to plug in here. So 30,000 minus B plus 0.08 B equals $2,100. So as you can see now I have one equation to work with and I have one variable, and I'm going to go ahead and solve it from there. So I'm going to distribute. 5% of 30,000 is 1,500. And I'm going to keep on distributing. So minus 0.05 B plus 0.08 B equals 2,100. And then I'm just going to continue working. I'm assuming if you're here, you're good at solving equations. So I'm going to continue by combining my like terms. So what I have is 1,500 minus, or actually plus 0.03 B equals 2,100. I'm subtracting my 1,500 from both sides. And I get 0.03 B equals 600. And again, we're just continuing to solve. I divide by 0.03 on both sides. And I get my B equals, thank you, $20,000. So the amount she invested at an 8% interest rate is going to be $20,000 at 8%. And again, we can solve for our other variable now. I know that B is 20,000 by using either of these two equations up here. It doesn't really matter which one you use. But again, looking back, I'm going to pick the easiest one. Well, I know A plus B is 30,000. I know B is 20,000. So that means that Mrs. B invested $10,000 at 5%. So $20,000 at 8%, $10,000 at 5%. And you can always double check this by saying 8% of 20,000 is 1,600, 5% of 10,000 is 500, add those two up and you get 2,100. So again, just setting up a system of equations is, I think, the most difficult part, and then from there you're just using some substitution and solving. So
Yeah, I was actually just going to say that even though the solving of the equation looks like the most complicated part, it's actually really not. It's coming up with those equations sometimes is what's difficult. But
that seems to be the part that most students get hung up on.
And what you did at the beginning with defining your variables, that tends to be the key to being able to do it.
Yeah, I feel like a lot of times students try to skip that step, I don't know, to save time, or maybe they just forget. But I feel like once you have those set up, it's a lot easier.
And writing them down too.
Yeah.
Just writing them down helps. Sometimes I think they don't set up their variables because they're like, well, I already know what they are.
Right, and then you forget at the end
And
of
then
the
you
But
day.
it is,
forget.
it's so useful. It's strange that it's such a tough sell for students sometimes to just show the work, that they're happy to do that work, but they just don't want to write it on the paper.
Exactly.
But then it can kill them later when they want to go back and say, wait, what did I do here?
It's very true.
Like I solved for B, but what is B? I don't know.
Show your work. We're not just being mean, I promise.
That's right. It's helpful for all of us.
All right, well, let's go back to Lily and get another social media question.
This one, as my assignment, talks about Yellowstone being a volcano, but I can't find any pictures of the volcano there. How can it be a volcano if there is no big mountain there?
Well, that sounds like a science question.
I like these.
Okay, cool. So let's see. Let me pull up a picture of a caldera forming, and we can talk about this. Okay, so volcanoes do not necessarily need mountains. We often associate volcanoes with mountains because many of the most famous volcanoes erupt from mountains, and there's a reason for that, but you don't necessarily need a large mountain to have a volcano. Volcanoes form really from two main things. We have, on the Earth, we have three layers of the Earth. We have the outer layer called the crust, a middle layer, which is liquid, called the mantle, and then an area right at the center called the core. And so volcanoes form because of the interaction between the crust and the mantle. So effectively what's happening is you'll have areas of thin crust where the mantle, which is liquid hot magma, is able to bubble up through. The most convenient location for volcanoes to form is going to be where tectonic plates meet. So for example, there are lots of places around the Pacific Ocean, both the American coast of the Pacific Ocean and also the Asian and Australian coast of the Pacific Ocean. There's lots of places where tectonic plates meet in that region. And so around all these coasts, you have a high incidence of volcanoes and then also earthquakes, which are both often caused by interactions of these tectonic plates. The volcano in Yellowstone is slightly different. It forms from what's called a mantle plume. So we effectively have an area of Earth's crust where the crust is fairly thin, and some of the magma from the mantle is able to bubble up into, and sometimes actually erupt. So I pulled up a picture, and it's not perfect, but if we could jump to my screen, I think it'll sort of do, and it is a little bit tiny, but hopefully you guys can see. It's 4 stages of what's called a caldera forming. So what we have here, in the first stage, we have a large magma chamber underneath, and there is a mountain there. I appreciate there is a mountain. It doesn't have to be, but there is a. Oh, really? Yeah, Nate, you're so smart. Look at you.
Not much bigger.
But slightly. I appreciate that. So in any case, we have this magma chamber forming, and then we can have a caldera, a crater for a volcano is effectively going to form when a magma chamber empties. And so we can have a giant eruption that's represented in the second picture with all the gray smoke up above. And then you can see, hopefully, in this third picture and fourth picture that we have some space created here. Effectively, after the magma chamber was emptied, the crust layer can settle a little bit. So in the case of Yellowstone itself, what we're talking about is a huge, huge area that has a giant caldera. In fact, it's something like 2/3 of the park are the caldera. It's like a 1,500 square mile area that is the caldera. And it formed from a gigantic mantle plume. And actually, I should say that's mostly accepted, but I think it's a little bit controversial as to exactly what causes this volcano at Yellowstone. But it's not even referred to as a volcano. It's often referred to as a supervolcano because of its size and magnitude. And along with that, there have been a series of super eruptions that have happened over the course of the last, I believe, 3 million years. So it's actually fairly recent volcanic activity. If you're interested in this, I strongly recommend looking into it. There's a lot of cool science happening around this, but also please be wary because if you go on the internet and search Yellowstone supervolcano, you will find a lot of information about how the supervolcano is going to erupt any day, that we're overdue for an eruption. And while it is possible that the supervolcano could erupt any day, there's no reason to see that it's more likely today than it was 20, 30, 50, 100 years ago. It could happen, but please do not be afraid, and I strongly, strongly recommend a visit to Yellowstone. It's an incredible park. Wow. That makes sense to you guys?
Yeah, it's
a
just
little
really
bit?
interesting.
Yeah.
It's really interesting.
Yeah, there's a ton of information, and I worry about that because I do see so many scary articles related to the Yellowstone supervolcano, and it's interesting and it's kind of scary, but I don't want people to be too
Right.
afraid. It's unlikely.
I was just looking at.
Did you find some?
Yeah.
Apparently, we are in the primary ash zone in
Oh, we are?
Colorado, so we're okay.
Yeah, the last time it erupted, didn't it travel all the way
Oh yeah, so if it did erupt, this is a whole other interesting thing. If it did erupt,
this
it would
is-
scatter
look,
ash
your
all
screen.
over
Yeah.
the United States. Oh yeah, perfect. So that's covering a large area of what
Is that really the kill zone?
no,
Well,
no.
I'm going
Kill
back
zone is
to
much smaller.
Michigan
This is
if that's the case.
this is the ash zone.
Wyoming is done.
So this is where the ash is going to settle. But the layers of ash would be so thick from this eruption that they say that it would stop agriculture in the United States
Okay.
for years. So think about what that would do to a country. We have this huge region is often called the breadbasket, much of what is covered there. And we're talking about not being able to grow crops in central United States for on the order of years.
That would
Think
be
about what that would
huge.
do to
Oh
our
my
economy.
goodness.
So not just the people who would be, I mean, in the immediate eruption zone, yes, that's scary. But it is, northwestern Wyoming. There's not a huge amount of people who live out there, not to be,
Right.
mean to the people in Jackson. But a big issue is just what's going to happen with the ash. And you would expect to see effects of this all across the globe.
Right.
That's a game changer.
Yeah,
My
so
teacher
let's.
had us watch Fantasia to learn about that, like in the scene where the dinosaurs were like dying off because the
Oh,
ash
sure.
was covering the sun, and it was a really sad part.
Yeah.
But it really was
Oh.
actually, it got the point across. So.
Yeah.
One of the largely accepted ideas now is that a meteor did hit the Earth, but that meteor caused a number of super eruptions on the opposite side of the Earth. Much like when you get your head hit, you can have a concussion form on the other side where your brain knocks against.
Yeah.
So it's like, and that would be where all that ash came from in the video.
It's interesting.
That is really interesting.
Lots of
I
stuff.
like it.
All right. It sounds like we actually have a caller on the line.
sweet.
so-
Ooh. All
Hello?
right. Hello?
Hi, can you hear me?
Hi.
Yeah,
Yeah,
hi.
we can hear you just fine. How are you?
I'm kind of confused. I have to write an equation that describes this information. You guys got something to write something down?
Sure. I guess I'll take this one.
All
All
right.
right.
Okay.
What is the information?
So there's two cars, an Edsel and a Studebaker, and they're 635 kilometers apart. They start at the same time and drive towards each other. The Edsel travels at a rate of 70 kilometers per hour, and the Studebaker travels 57 kilometers per hour.
All right.
And how many hours do the two cars meet?
I lost you there. Back up just a minute. So the two cars.
Yeah.
So two cars. Are they traveling towards each other?
Yes.
Okay, they are traveling towards each other. Oh, this is a rate problem. These are my favorite. All right. So
This is the standard torturous algebra problem that everybody always.
right, the two trains traveling towards
Right.
each other. When do they hit or something? Okay. All right. I'm sorry. So two cars traveling towards each other. They're 635 kilometers apart. I forgot that part.
Yeah.
Keep going then from the 635 kilometers.
So the Edsel's traveling at a rate of 70 kilometers per hour.
So I don't know what kind of car that is. What is it? Do you guys
It's
know?
an Edsel.
What's an
Sounds like an
Edsel?
old car. I mean, a Studebaker is a pretty old car, so.
Okay.
Sure.
I'm going to call it car A. Can I do that? Car A.
Okay.
How fast is that traveling?
70 kilometers per hour.
And why? Okay. Per hour. Gotcha.
And I guess you'll call the Studebaker car B.
Sounds
It's
great.
traveling at 57 kilometers per hour.
Okay. Gotcha.
And it says, in how many hours will the two cars meet? I'm stuck on the whole thing because I don't understand this kind of problem.
Okay, how many hours? Okay, I think I can walk you through this. So how many will they meet? So we've kind of got to think about the situation, what's happening and what we know and what we don't know. And typically, part of the reason why I said, oh, this is my favorite kind of problem is because it's a distance, rate, time problem. Your distance in general is going to equal your rate times your time. And we're going to use this equation kind of as our model to help us write one equation for this particular situation. And here's what I mean. So you gave me the rate of car A, so I'm going to call it rate A, and that is equal to 70 kilometers per hour. You gave me the rate of car B, which is 57 kilometers per hour. The distance, let's say this, we'll say the time, we can say that the time of car A is, even though we don't know what it is, we know that it's going to be the same as the time of car B. So however long it's taking car A to get X distance is going to be the same as it is for car A for them to meet. They're going to be traveling for the same time period. Does that make sense?
Yeah, it would be hard to crash if they weren't in the same place at the same time.
That's very true. Exactly. So we know our time A is going to be equal to the time B. We also know our total distance is 635 kilometers. So we could say distance A plus distance B is equal to 635. And then I don't know if you've seen some of the information or some of the problems that have been going on here before, but we've been doing systems of equations. We can potentially use this information to get us a systems of equation. Our goal is basically to get one equation, one variable. And our issue is that we have three. So we could, here's my thought anyways, is I'm going to take this equation here, I'm going to solve it for t. So basically divide both sides by the rate. So we could call time is going to be equal to the distance times the rate. Does that make sense?
Yeah.
So you can kind of write that equation a lot of different ways, but we're going to use it in this form. For my time A is going to be equal to time B. So time A, I could say time A is also equal to distance A divided by rate A. Now we don't know distance A, but we do know rate A. So let's say time A is equal to distance A divided by 70. Then we could also say time B is distance B divided by rate B, which we also know rate B, which is 57. Actually, let's do this. Oh, we know time A is equal to time B, so I'm going to go ahead and say distance A over 70 is equal to distance B over 57. So I basically took this and said it was equal to this because the time of both cars, it's going to be the same. So now I'm going to take this equation. Let me kind of separate them here. This is not very neat, I'm sorry. I have that equation, and then I also have this other equation, dA plus dB is equal to 635. So wait, let me back up though really quick. Does that make sense, kind of what I did?
Yes.
Okay, you're following me so far?
Yeah.
All right. And really, I'm kind of working this out as I go, and I don't know if this is just because rate problems are not my favorite. I tend to work them out as I go, and I play around with it. But that might actually be a good strategy to play around with, okay, I know this, I know this, I know this. How can I put that stuff together? That's kind of what I'm doing right now. I've gotten to the point where I have two variables, two equations, which is great. And I'm going to do the same thing that Nate was doing earlier in the show, where he took one of his equations, the simpler equation, and he got one of the variables by itself. So I'm going to look at my second equation. Since that's simpler, I'm going to subtract distance B from it and call it distance A is equal to 635 minus distance B. Then what I can do is replace in this equation up here, replace distance A with 635 minus distance B. So I'm going to do this over where I've got a lot of room here. 635 minus distance B over 70 is going to be equal to distance B over 57. Now, what was your requirement now? You just had to write an equation?
Well, we had to write the equation, yes. And that seems to do it.
So, I mean, and there are a bunch of different equations, but if you're looking for a way to write an equation that you can actually go and solve, this is one of the equations you could write. There are definitely more ways to go about this is not the only way, but your goal is to kind of get it down to where you have one equation, one variable, and if you can figure out one of those, you can kind of go back and figure out the rest of them. So this is one of the equations that would work.
Okay, thank you very much for your help.
No problem. I hope that made sense.
It did. Bye-bye.
Thanks.
Yeah, I think there are a lot of ways to do those problems. So you can just manipulate a lot.
Yeah. And honestly, these are my least favorite problems, the distance, rate, and time.
Yeah.
And so you can kind of see someone who struggles with them, how to maybe struggle through it, if that maybe that helps.
Yeah. So I think we're going to go to commercial, but when we come back, we're going to do a little experiment. Sam, do you want to talk about that?
Yeah, so we're doing starting last week and then this week and going into next week, we're doing a little bit of food science. So last week we looked at making butter. Check out that video on our Facebook page if you're able to. Today we're going to look at making kimchi. So we'll see what you guys think, and we'll see after the break here.
Well, hopefully this doesn't involve me shaking kimchi for 10 minutes.
Yeah, it's going to be easier on your biceps this time.
All right. All right, we'll see you back after the commercial.
All right, see you soon.
Nearly 100 years ago, a Denver school teacher by the name of Emily Griffith opened a school. Not just any school, but one where Emily hoped that any working person who had an hour or two to spare may come and study what they could to make life more useful. She knew she wanted to call this school Opportunity. And on September 9, 1916, the doors opened for the School of Opportunity. The popularity of the school was a surprise, as she had hoped for 200 students to enroll that first day. Instead, she ended up with 1,400. The school started with classes ranging from telegraphy to typing, culinary to hairdressing, also English for the immigrants that were flowing into the state, so that they too could find meaningful employment, an effort close to Emily's heart. As the needs of the community changed, so did the School of Opportunity, adding courses like machine shop for the war effort and nursing, also many business classes. Emily retired in 1933, and against her objections, the school was renamed in her honor, the Emily Griffith Opportunity School. But the story does not end here. Emily Griffith Opportunity School is now Emily Griffith Technical College, a name that better reflects the current times and needs for the business world. More than 50 career training certificate programs with hands-on education and training in health sciences, business and technology, creative arts and design, and trades and industry.
I love Emily Griffith. I love the teachers, I love the program, I like the people that come here. There's a huge diversity.
And we still have Colorado's oldest and largest English as a second language program with more than 40 day and evening classes.
ESL program is very important for me because I need to improve my level of English. I can here improve my level completely.
Plus, the least expensive college programs in Colorado with financial aid and scholarships. Many students even graduate debt-free.
It has taken care of my education completely. It has paid for my schooling and my supplies.
So many programs to fit any person's needs. And we are still growing.
The vision of Emily Griffith Technical College is to be the premier college of excellence in the delivery of career and technical education. It's very exciting in that we can house most of our functions in this brand new downtown campus, serving our students just as we had in 1916, providing opportunities for all who wish to learn, as well as our location at 200 East 9th, where our video production program is housed, along with our broadcast studio. And we recently have moved into our new branch campus at 1205 Osage Street, which will house our College of Trades and Industry, a state-of-the-art facility that houses 50,000 square feet of instructional programming. With our 50-plus certificate programs spread out among 3 different campuses, we're hoping to build capacity, continue to offer the same grade instruction at the least expensive tuition point in the state of Colorado.
We truly do offer opportunity.
Opportunity.
Opportunity. Opportunity.
Opportunity.
For all who wish to learn.
Okay, hey guys, so welcome back to the Science Experiment Laboratory here. Today we're doing another food science demo and we're looking at how to make kimchi. Okay, so do you guys happen to know where does kimchi come from?
Korea.
In Korea, nicely done, Nate. In Korea,
Cabbage, right?
it is made of cabbage. It comes from Korea, and it's a hugely important dish for the Korean nation. So much so that like this was maybe 4 or 5 years ago, there was a cabbage shortage in Korea, and it was called by the press there a national tragedy, the lack of cabbage, right?
That's
and
sad.
there was a time when a Korean astronaut went to the space station, and for that mission, Korean scientists worked for years and poured millions of dollars into developing a special kind of kimchi that can be taken to space, where cosmic rays from the sun would not mutate the bacteria and make them potentially dangerous.
Well, we went to Jamaica for my sister's wedding, and my mom had to bring kimchi with her
Really?
because we were going to be there for 3 days. So.
Yeah, that's awesome. So for people who really care, it's a big deal. And
Yeah.
let me say right here at the beginning that I have never been to Korea and do not really have any connection to Korea or Korean culture, but I love kimchi. I come to it by way of a guy named Sandra Katz. This is one of his books. It's called The Art of Fermentation. He has a simpler book called Wild Fermentation. And the idea is that you can do fermentation in your house, at your home, using wild bacteria and wild yeasts that are living on foods that we use. Okay? So that's what we're going to try to look at today. The first thing I'm going to do to try to get this going is I'm going to ask Lily, can you coarsely chop the cabbage here? So our number one ingredient is going to be cabbage. This is most of what kimchi is made of. You can pull off the outer 2 leaves and coarsely chop the rest.
All right.
Coarsely chop the daikon radish. This is a kind of radish.
Because I hate cabbage so
Any
much.
which way that you get it, it can
I
be
really
coarsely
do.
chopped. It does not need to be perfect. And as you chop it, as you get chunks, I want you to just throw them in this bowl, okay?
Alright.
And then we're also going to coarsely chop the carrots. Now, let me also say that in my book, there is no one way to make kimchi. This might be heresy to some folks. In Korea, I don't know, but I have heard that in Korea there are as many styles of kimchi as there are families in Korea.
Chop it.
So the particular style that I make is
So you can chop it in half. And
carrots, radish, and cabbage. Yep, so just chop it right in half. Careful with your fingers.
I can already smell the cabbage.
Oh yeah, do you have a hard time with cabbage smell?
Yeah, I do. It's like worse than onions, to be honest. It makes me cry.
Oh, okay.
It's
Go
just
easy
so
there.
bad.
Go easy there.
Yeah. My mom used to make me eat cabbage as a kid, and I hated it so much.
Right on.
Oh. And
Careful those fingers.
actually, yeah, I know it.
So
this is actually
while we're waiting, do you want to help her out
Try.
there, Becca?
Oh,
yeah,
yeah.
sure.
Cool.
You want to?
it's very
Mike, I'll show you how it's done.
tough.
So while we're kind of getting this stuff chopped up, this is effectively a form of
It's just hard to do.
Tough cabbage.
this is effectively a form of pickling. Do you guys know what kind of liquid do we normally use for pickling?
Vinegar, right?
Yeah, vinegar is going to be, so normally take
This is tough.
cucumbers, you can put them in vinegar, you can
It
make
is, isn't it?
pickles. This is a form of pickling, but we're actually just going to use salt
There we
water.
go.
We're going to
Oh.
use brine nicely.
And then you can kind of just go
It's a
from.
good chop.
Go
Yep.
from
There we
there.
go. Yeah, yeah.
All right.
All right.
So as you get those kind of coarsely chopped chunks, you can just throw them in there.
Yeah,
Okay, and then what we're going to do is the first step of making kimchi is to get all of your main vegetables set up, and then what we're going to do is cover them in salt water.
Throw that
Okay,
Yeah.
and Nate, I'm going to estimate that we're going to need about 4 cups of water to cover all of this
Okay.
cabbage and carrots. And so to go along with that, we're going to need salt. Becca, could you pass the salt to Nate?
Thank you.
All right, so Nate, we want to do a lot of times recipes will call for 1 tablespoon per cup of salt. But what
That's
we're
good.
actually going to do is we're going to cut that in half and do 2 tablespoons per 4 cups, just because I think that a little bit less salty comes out with the tastier kimchi. Again, there's no one right way to do this. There's just a general process. So what I'll have you do first, Nate, is actually measure out 2 tablespoons of salt and pour them into that.
All right.
Oops, I leaned.
Oh, I think there's a break on the table.
Oh, nice.
Yeah.
Nicely done, guys. I should have brought 2 knives. I could have had you both chopping at the same time.
Yeah. Putting us to work today.
That's
So
right.
2 tablespoons in here? Or
No, sorry, let's put them in here,
here.
and we'll actually mix the salt water.
Okay.
So what we're making here is a brine, and you can do different levels of brine as you're making different kinds of fermented vegetables. And actually, let me just say that you could do this with any kind of vegetable. The process that we're doing right here works with practically anything.
Oh, that's interesting.
My principal loves pickled okra, and so I have a standing promise
never
of
had
making a jar of pickled okra.
Could
And
you
I'm gonna
bring
do it
some in
this
for
way.
us too? Because
Yeah,
I just have never
absolutely.
tasted it.
I would love to do that. All right. So
How's
now
this?
the other thing that's going to be
Okay.
happening here is we're talking about fermentation. Okay, and there's a special kind of fermentation that's going to happen here, and it's actually fermentation that happens in our bodies as well. And the fermentation is called lactic acid fermentation. Have you guys
Oh,
ever heard of this before?
Yes, when we work out. That's why our
Yes.
muscles are sore.
So good, Becca. And so why is it that we do lactic acid fermentation when we're working out?
Anaerobic something.
Oh, yes.
Respiration,
perfect.
anaerobic
Yeah,
respiration.
wonderful. Anaerobic respiration is the opposite of
Aerobic.
Aerobic respiration, very nice.
I win.
Yeah, you did. Second.
Sorry.
Oh, very nice. You guys
Not
are
on the
very
distance
good.
rate problem, but.
Yeah.
So the deal is going to be that we have anaerobic respiration and aerobic respiration. Aerobic respiration, aero, requires the presence of oxygen, whereas anaerobic respiration requires an absence of oxygen. And what we want to do here is we want to encourage anaerobic respiration. And we want to encourage anaerobic respiration because almost coincidentally, a lot of the bacteria that live anaerobically tend to be fairly healthy for us humans, whereas a lot of the dangerous bacteria tend to be aerobic bacteria.
I did not know that.
Also, aerobic respiration is happening in things like molds and yeasts. So if you have molds and yeasts growing, they're going to need oxygen to function. And so if you can eliminate the oxygen, you can prevent the growth of molds and yeasts. That makes some sense?
Yes.
And
Did
I'll
not know
actually-
that.
I'm going to have you guys hold off right there. That's plenty of cabbage. We'll just stop right there. We can
right.
coarsely chop the radish and the carrots.
Alright.
And actually, even as I'm saying this, I'm realizing, for the sake of timeliness, let's just do the cabbage for this, okay? And we'll move on. So while we're doing this, Becca, will you chop the onion just enough so that we can fit it into the food processor?
Sure.
And do the same with 1 clove of garlic and the peppers.
Sure. You got it.
Okay. And then what I'm going to do is pull a little cooking show.
Not a great knife.
Smell like cabbage.
So what we would have done here is we would have poured water into our salt right here. We would have tried to make a brine that was, again, 1 tablespoon salt for 1 cup of water. And we would want to just completely cover our cabbage and our other vegetables, our coarsely chopped. And we would leave this sitting for about a 24-hour period.
Is that hot or cold water?
Just room temperature water is fine, not hot, because we really don't want to cook it at all, but it does not need to necessarily be cold. Okay, so let me move this stuff off here. And here is some stuff that I chopped up for us last night, and I let it sit for 24 hours. So we have same things, daikon radish, carrots, and cabbage
Is this open?
chopped for us.
Or do I stick it in
I
there?
think you just stick it.
So hold off on that. So I will walk you through that. Would you just get it chopped and ready to get into that?
Sure.
Yeah.
Oh, there we go.
Okay, so at this point, what we've done is we've actually started something that is going to seem really similar to sauerkraut, if anybody knows what sauerkraut is. So sauerkraut is just
yum.
brined cabbage that's allowed to sit for a long time. And if we just let this sit covered, we would end up with something akin to sauerkraut.
Really?
Yes.
Oh.
So kimchi is often called Korean sauerkraut, and I think that's a little bit offensive. It's oversimplifying things, but there's a really similar process here. So the major difference here between sauerkraut and kimchi is going to be that after the initial 24-hour soak period of our veggies, we're going to make a paste out of garlic, red pepper, and onion. And actually, there should be ginger also, and I do not know where the ginger went to, but for folks at home, you should include ginger in the paste that we're about to make. Ours is going to be gingerless.
Gingerless.
Which is actually okay. Again, these variations are totally fine. Traditional kimchi would have ginger, and something that I wouldn't have used anyways is fish sauce. But a very common ingredient in kimchi is, in the paste, is going to be a little bit of fish sauce. I don't use it because it's harder for me to get to an Asian grocery store and find it, but if you have access to one, it can really improve the flavor of your kimchi and make it more complex. All right, so we got a couple. That's actually enough garlic right there.
Okay.
I'm going to chop off the
thinking the
tops
same.
of those 2 red peppers. Ba-doom.
Your knife isn't very sharp.
Apologies.
That's why we've been struggling.
All right. And then what I'll have us do, what we want to do right now. Oh, I see what we did. Okay. Well, we're just going to do this, and I'll take care of that later. So, what I need to do first, I need to drain this water off. Well, Becca's getting this already. So can you, I got a little special draining lid here. Can you hold that guy on and drain the water into this bucket?
All right.
And Becca, at the same time, you can put the lid on the guy. Turn it, pull out that black piece. And then what we'll do is we'll turn it on, and we just kind of want to turn this and just go ahead and turn it on. Okay, that's pretty pasty. Are there any big chunks that crept up along the sides, or does it look pretty well chopped?
It looks pretty well chopped.
It should be just a little beyond diced. We call it a paste a lot of times, but just a little
Yeah,
beyond diced.
looks pretty
and that looks
chopped.
pretty perfect for our purposes. Okay, so you get your paste, and you've got your veggies that are soaked for 24 hours. You dump the
Water in.
salt water off. And so at this point, we just have sort of loose cabbage, carrots, and daikon radish that have been soaking in salt water for 24 hours. So at this point, what I need us to do is I need us to actually mix that in. So if you could pour this in, and I've got that little stirrer right there, that little spatula, I should say. Yeah, perfect, Becca. And if we were at home and we had access to a sink, what I would actually recommend is that we just wash our hands with soap and water and then get our hands into it and mix up the paste with the vegetables just by hand. Since we don't have access to that tier,
it's potent.
And
it's making my face water right now.
I bet. Between the peppers and the onions.
Yep.
Right.
And the garlic too.
So yeah, just as best you can. And actually, since we have the lid, we could maybe just do. I told you I wasn't going to work your biceps, but
Oh, I gotta do
we
this
are
again.
going to do it this time. So
It's okay. I've
I
been
do this-
conditioned over the last
yeah,
week.
that's right. That's right.
So I'm just shaking this up?
Yeah, just shake it and kind of vigorously back and forth. I want to get it all spread around.
All right. Oh, yeah, it is strong.
Yeah, there you go.
I am really
It's
watering.
potent, isn't it? And really, as this stuff
Garlic
ferments, if you
does
decide to do
this
this
to
at home, the smell is strong, and it will pervade your
It's
home.
good.
In a
It's
good way.
just really strong.
My mom has a separate refrigerator for kimchi.
For kimchi, there you go.
She
Oh,
does.
that's
Because
amazing.
everything will smell like kimchi.
That is awesome. Okay, so let's see what it's looking like now. Yeah, nicely done. Okay, so
Oh,
it's pretty
looks-
well mixed up.
Looks really
It's kind of got
good.
that kimchi color. Now, I should also make one really important point. Traditional kimchi is often made with Napa cabbage. It's a softer, more lettuce-like looking cabbage. I use traditional cabbage just because I think it's a little crunchier, and I like the flavor. Again, there's no strict rules here. You can use Napa, you can use regular. It's going to work out pretty well, much the same. Okay, so at this point we have our vegetables. They've been salted, they've been soaked. They sat overnight, then we mixed in the paste. Okay, and so we're very close to actually being done. I said we want to promote anaerobic respiration, so lack of oxygen. How could we do that? How could we prevent oxygen from getting at the veggies?
Put it in a container,
Jar would be great.
airtight.
And we could do airtight, but I actually don't usually do airtight. I kind of just let it, I have sort of a loose jar on top.
Mostly airtight.
The main way we're going to do it is we're actually just going to keep everything submerged underwater.
Oh, okay.
Oh,
Well,
okay.
So
you
this is
know.
what we're going to do. I
makes
got
sense
this
as
fancy
well.
kimchi fermenting jar here. I use a couple of jars like this at home. And you can see it's not really an airtight lid. It just sort of sits loosely on top.
Makes sense.
Okay. And so what I'll have you do is Nate and Becca, could you guys kind of work together to get
Sure.
that in there for me?
If you hold the pot, I'll be a scooper. Well, I'm a messy scooper.
That's right. And kimchi's a little bit messy, but it's a
Oh.
really,
It
it's a
is.
fun, messy process.
It wouldn't be fun if it wasn't messy.
That's true. That's true.
All right, almost there.
And typically when I make batches, I end up making about double what we did right here. So that would be something like 2 heads of cabbage,
All right.
a full-size daikon
Red.
radish, and maybe
All right.
4 carrots. Okay, beautiful, beautiful. Okay, so at this point, what we would typically do, again, I would have you guys wash your hands, and we would actually try to press this down as much as possible. But since we haven't totally sanitized our hands, Becca, will you push it down with just that little spatula, just as best you can?
Like my eyes are watering quite a bit.
Oh, I bet. I'm actually doing okay
I'm
over
getting
here.
used to it now. I'm
Oh,
okay.
good. Oh, I love to hear that. So you can see there is almost a little bit of water, and if we push down pretty hard, there's a level of water that's rising here, but it's not enough to totally submerge the veggies.
Yeah.
And that's what we want to do is we want to submerge the veggies. And along with that, what we want to do is make sure that the veggies stay down when we pour the water in. So we're going to use my fancy rock and plate system. This is very close to what's done in a lot of traditional ways, although it's often a wooden plate and then maybe fancier stone. Now this is the stone I just got out of my yard, but I boiled it for 10 minutes, and I use it in a lot of different kimchi. It's been used about 20 times. It works great. But if you're going to use a rock from outside to do this, boil it first to clean it.
Good call.
So this plate is pretty perfect because it fits right inside, and it covers a lot of the cabbage pretty well. This rock's going to be placed on top for weight to keep most of that down. And then, Nate, since you're closest, I'm going to have you do this. Can you pour just gently that in there? And we just want to get it to a level where it mostly covers the cabbage. Okay,
Nice.
let's do a little more. Go even a little more. Maybe a little more.
All right.
Sorry, it's just,
Would it be would it be bad if you filled it too much?
no, not necessarily. Go ahead and fill it a little bit more.
Does
just
it
for-
dilute the flavor, or do you drain it later?
You can drain it later. And you could drain it later. I like to have some kimchi juice. You just ultimately do want it to be mostly veggie and not
Right.
a lot of extra juice. But no, there's no reason why you couldn't fill it out.
Okay.
So at this point now, I'm not going to say that this prevents all oxygen from getting in. some oxygen will dissolve in the water right at the surface level, but this is going to prevent a bulk of it from getting in. There's not going to be as much oxygen in this water as there is in the atmosphere, which is really going to prevent the growth of, again, bad bacteria, yeasts, and molds, and that's what we want to do. We want to encourage the production of this one kind of bacteria called lactobacillus. So really that's a genus, and there's lots of different species of lactobacillus. There's even a species of lactobacillus named Lactobacillus kimchi, and that species of lactobacillus is often found right on raw cabbage leaves. So a lot of those raw vegetables that we put in had living bacteria on it that are going to help this fermentation. Another reason we don't totally want an airtight lid, and this comes from that wild fermentation idea, some of the bacteria that we'll get will come in from the outside. And we don't actually mind that gas exchange. It's okay for some of the bacteria to enter in there because the salt and also the lack of oxygen in the water is going to really encourage the growth of healthy bacteria and prevent the growth of unhealthy bacteria.
Makes sense.
And it is a little bit haphazard in this modern American world where we're so concerned sometimes with germs and keeping clean and sanitation. This can maybe seem a little unsanitary, but this is an ancient process that's been going on for a long time, and it's very safe. And I can speak from personal experience. I love having kimchi around, and I think it's a ton of fun to make. And it's one of these gut foods that's good for your gut health because you're adding probiotics, living bacteria, healthy bacteria.
So how long do you let it sit for?
Great question. So at this point, we would let it sit for anywhere from maybe a week to even up to 4 weeks, or even longer, at room temperature. Okay? If we let this go for a few days, what's going to start to happen is we will get bubbles coming up around the side that would tell you that it's working. Okay, now sometimes it can get contaminated. You can get molds growing across the top, and that would be a reason to pitch your batch of kimchi. But for the most part, that should not happen. And as long as it gets going a couple weeks and you've got the bubbling happening, you know that the fermentation is occurring. And you can even taste test it as you go along. So every couple days, pull out the rock, pull out the plate, taste it, see how it's going. And you'll notice that over time, the taste will shift as the bacteria do their work processing a lot of the different molecules in the food. So yeah,
very
cool, right?
Yeah.
So it is just one last step here, guys. So we would have to wait, right, like 3 weeks. Oh, and another big thing is going to be how cold or warm is it where you're keeping it. In my house right now, it's about 62 degrees. We keep it pretty cold in the winter. So I would leave it out for 3 weeks. In the summer, when it gets to be like 75 degrees in my house, I would probably only let it out for a week because the fermentation will happen so much more rapidly in that warmer temperature. So in this case, I just have stuff that's actually sat a week and a half in my house, so it could have gone longer, but it did not, and that's okay. And I'm just going to do this guy right here. Don't worry about that. Pay no attention to the green bowl. So I do want you guys to just be able to try a little bit of kimchi. Okay, I have my big kimchi chopsticks, and then I have a fork. What I'm going to have you do is, if you're up for trying a little bit, would be I'm just going to put some in the bowl, just fork a little piece and pull it off the fork for yourself, and then pass it along. Does that sound okay?
Sure.
Look at these sweet big chopsticks I have. Aren't they cool?
Those are pretty cool.
Those are huge. They're gigantic. We got them in a dollar store in Taiwan.
Oh, it smells really good.
Yeah, and so you guys will be able to tell. I mean, think about what cabbage tastes like, and this should taste much more pickled. And you can see there's a little bit of radish in there, there's a little bit of carrot. And give me your honest opinion. You do not have to love it, but I've been surprised by how many people really enjoy this stuff.
It's good. How does that compare to your mom's kimchi?
Pretty good. It's a lot less spicy than I'm used to.
Yeah, and actually I specifically made a non-spicy
Aw,
batch,
thanks.
thinking that maybe we wouldn't mind. So you can do, I think in this one I did 4 peppers and
Okay.
2 cabbages. I think typically I would do more like 8.
Yeah, I'm used to like a redder kimchi.
Yeah, absolutely.
I think that's more.
And actually, so this is purple right now, and the purple
Did you
is
like it?
from,
It was
actually pretty good.
we made this with red cabbage at home, and then we just did green cabbage here on the show.
Okay.
So the green cabbage it'll just stay sort of clear and green. But if you use red cabbage, it stains your cabbage this kind of beautiful purple color, which I really love. So
Very
what do you
cool.
guys think? What flavors? What are you getting?
Yeah, it's pretty good.
Nice. Did you get a little garlic? Can you taste the garlic?
I can taste the garlic.
And
It's
the
great.
ginger, the ginger is really strong in this batch, I felt like.
I like
Cabbage was
this
actually
one.
really good. So, and I usually don't like cabbage, so it was actually good though.
Right, well, I
I
mean-
could taste it, but it didn't taste like horrible like my mom
Cabbage.
used to make it. Sorry, mom, but
It's just so much different. Fermented food is just so much different. It's like if you went off and ate a coffee bean off the tree, it would not taste like coffee. It's after the fermentation
I
process.
think we are, not to cut you off, I think we're running out of time here.
Oh, I'm so sorry.
we gotta,
I'm just so excited about kimchi.
Gotcha.
Thank you guys so much for watching.
Understandably.
Tune in next week for more kitchen science. See you later.
Emily Griffith Technical College is turning 100 years old, and we want you to join in the fun. The Emily Griffith Foundation is presenting a year-long community celebration, opening doors of opportunity for 100 years. Here's how you can play a part.
Are you 1 in 2 million? Shop Automotive has donated a 3-year lease on a Mini Cooper that one lucky alum of Emily Griffith Technical College will win. All you have to do is sign up.
Go to egfoundation.org for more information.
Hello. Hi. What are you waiting for? What are you afraid of? You jump right in. Shooting video. You have a camera in your hand more than a book. Learn from my dad. He won't waste your time. Learn video production. My dad would teach you. You can do this.
Welcome to Nerd Necessities Network. You're probably thinking, what is Nerd Necessities Network? That's a good question. Nerd Necessities Network is a premier DPS TV show all about nerdy people, places, and things. Check us out on Facebook and YouTube and all the social networks. That's a wrap!
There's times when you wander and ponder all the labels you've received.
Believe me, I've got a few. Never mind from when, why, or how.
'Cause now, everything's different. I found the perfect place.
A space where the labels fade and I'm accepted and supported.
Check what the news reported. Emily Griffith helps all who wish to learn.
Turn towards your future while you finish the basics on your time.
Prime opportunity in this mature environment.
The only requirement is motivation and thirst for success.
Invest in your passions. There's no limit to how far you'll go.
And know that you'll have something in common with everyone here.
We all chose empowerment over standing still in fear.
Hi, welcome back. Hopefully you liked our I guess you could call it an experiment.
Yeah, sure. Sure.
On
Demo,
kimchi.
science demo.
Demo, there we go. Actually very, very interesting and very tasty. So science and food.
I'm glad you guys enjoyed it.
Loved it, loved it, loved it. So we're running out of time, but we'd like to give you a chance to answer our trivia question because we haven't had a winner yet. So Lily, what's our trivia question? Let's repeat it for our
Our trivia
audience.
question was, which industry gave us time zones?
So if you've got an answer to that, call in kind of soon. We're going to answer one question, and then we're going to get to the answer to the trivia question. So got about 3 minutes. All right, so we do have a phone call, I believe. Do you hear us? Are you
Can you
there?
hear me?
Hi, thanks for calling Homework Hotline.
Yeah, I'll answer one question and you answer one question.
Okay, do you have an answer to the trivia question?
The answer to the trivia question is the railroad industry.
That,
you were exactly.
That's correct.
That's correct. Yay!
I think your prize is somebody will answer your other question.
Isn't that a great prize? That's great. No, we'll really get you a better prize than that, but.
Okay, so my question is, why do people blame CO2 emissions for global climate change?
Okay, cool. Well,
Educate our audience.
I will take that one for you. So this has to do with the way that the Earth traps heat and CO2's role in that, okay? So can you picture a CO2 molecule? Do you know what we mean when we say CO2?
Uh-huh.
Okay, yeah. So like one carbon with 2 oxygens hanging on the end. And you can imagine, right, there's a lot of intense energy coming down from the sun in the form of ultraviolet rays, right? And the energy coming down from the sun is hitting Earth, and something on the order of like 70% of what the Earth gets hit by gets absorbed by the Earth, and then about 30% of it is going to be reflected back off into space. And if we had no atmosphere at all, then all of that stuff that would be reflected would just totally escape into space, and the Earth would be very cold. Does that make sense so far?
Correct, yeah.
Okay, cool. So the reason that CO2 is blamed for global climate change is because it's thought to be part of a group of gases that are increasing the temperature of the Earth. And that's simply because as energy radiates back off the Earth, most of the air, most of the atmosphere is made up, 90% of the atmosphere is made up of nitrogen gas and oxygen gas. And these are two gas molecules that just do not really have the ability to trap heat. And it's because they're simplex. But a more complex molecule like CO2 or an even more complex one like CH4 methane is going to be able to essentially absorb some of this energy and hold on to it, re-emit it back to the Earth in a way that would increase the temperature or at least keep some of that heat on the Earth. So actually CO2 is really useful because it keeps the Earth warm to a point where we can actually live here. But the concern is that as CO2 levels rise, and again, not just CO2, but other gases like methane, as those levels increase in our atmosphere, we could have increasing temperatures, and then it's thought that those increasing temperatures are throwing off normal weather patterns. Does that make some sense?
Yes, it makes plenty of sense.
Cool, and so that's a little bit of a loaded question, I think, because there is a lot of debate around this idea, but as a scientist, I feel like this is pretty clear science. Yeah. So do you have any follow-up questions with that?
No, sir.
Well, I'm going to leave it at that. Thank you so much for calling in.
Thank you.
All right.
That's very true. The science does not lie.
Right, right. There are things to be debated. There are things to argue
about.
Yes.
But actually, let's talk about the railroad industry and time zones. I just think that's so interesting. First off, the fact that time zones are not even 100 years old. That's kind of a new-ish thing. There was no need for time zones before railroads because we weren't traveling so quickly from place to place, and every place just basically set their time based on when the sun was highest in the sky. That was noon. And as you can imagine, noon is at different times depending on where you're at.
Yeah.
And so the railroad was the reason why we have to coordinate those times.
Yeah, so I guess the time zone idea was developed by Sir Sanford Fleming, and he developed it. He actually proposed that we have 24 different time zones. That was based on really just that we have 24 hours in a day, and the Earth is 360 degrees, right, because it's a sphere. So each time zone represents about 15 degrees of longitude based on that 360 degrees divided by the 24 hours in a day. So that's kind of interesting. I thought how that came about, like where they determined
how they determined where
change
those
the time
lines
zones
are.
every 15.
And of course, there are some exceptions because there are times. Well, okay, I lived in Louisville, Kentucky, which is Eastern time zone. But if you travel due north to Chicago, it is it's Central time zone, and it I don't know.
A little confusing.
Yeah, so there are some exceptions, of course, but the general idea is we're just split into 15-degree segments so that the sun is at the highest point in the sky at noon at every one of those places.
Well, it does seem like it does create some little confusions, but I do think that it fixes things in a way that back before. So I was reading that when the Transcontinental Railroad was laid down, it ran through 8,000 towns, each with their own time zone or time system.
Time,
based on their own local, their own interpretation of what was going on with the sun. And so setting up the time zones really served to kind of unify the world and make it possible for the railroad to function.
I also thought it was interesting. I was talking about exceptions. So China is the largest country with only one time zone. You would think that, and actually, if you were to divide it the 15 degrees, it should span 5 time zones, but it doesn't. And that would kind of actually, the comparison would be like having New York, Chicago, Denver, and LA all being in the same time zone, which is really interesting. So there are exceptions to it, I mean, but it does. It's a system that works. It unifies us. So, well, all right. It looks like that's all we have for you for our show today. I hope you enjoyed our science demo with the Kemchi and Sam. We will see you next week, Tuesday and Wednesday from 4:30 to 5:30. So if you didn't get your questions answered, call us then. In the meantime, check us on Facebook and Twitter. And we hope you enjoy the rest of your week. Take care.